All right, chapter 4, lesson 8 talks about quadratic functions. And I talked to you a little bit about this in lesson 7 whenever I said that now some of our functions will not be straight lines, so they're going to be curves. So that's what we're talking about whenever we're doing quadratic functions. So just because it's a word that you've probably never heard of, let alone said before, let's just talk about what it means. So right here it says a quadratic function is a function in which the greatest power of the variable is 2. So in other words, you're going to have some x squareds, not just y equals mx plus b, but you're going to have x squareds in there. Its graph is U-shaped. So whereas before you've only had lines that were straight this way or this way. Okay, so now you are going to have, your graphs are going to look like this. Okay, they could also go down, but they are going to be U-shaped. And those are actually called parabolas. So the word actually looks like parabola. Please, please, please don't ever say it's a parabola, because it's not. It is a parabola. That's what they call it. So when you talk about quadratic functions, the function in which the greatest power of the variable is 2. So again, that's that x squared that we're talking about right here. So this right here, true. We're talking about true and false. The graph of the quadratic functions sometimes open upwards. Sure, that's true. The graph always opens down. Well, obviously not if it can open up part of the time. The graph is a straight line. Is the graph a straight line? Are these straight lines? No, they are curved. So that is false. They are a curve. They are not a straight line. So that's what we talk about when we talk about quadratic functions. So let's get right into some and graph them. Prepare to behold the beauty of a curved line. I know, I'm weird. Oh well. All right, quadratic functions. Again, y equals mx plus b out the door, because now we have squared term, a squared x. So this is the function, quadratic function form, y equals ax squared plus bx plus c. Now, you will rarely see all of that on there, especially in what we're dealing with right here. We just have y equals x squared. That's the basic quadratic function. All right. So I know I've told you before, whenever you make a line, I tell you to have 3 points. Well, because you actually have 2 parts here, you have the part over here that's negative and the part over here that's positive when we talk about x's, I would like you to have 5. And it's not just me being mean that I want 2 more points than I normally do, but it will help your graph turn out better. Okay, so whenever I say I want -2, -1, 0, 1, 2, let's get to a graph here real quick. So we have y equal x squared, and if I say I want -2, -1, 0, 1, 2, that just gives me some negatives, 0, and some positives. All right, so if I put in -2 for x, now notice that this is x squared. So if I put a -2 in here, that's -2 times -2, which is 4. -1 times -1, 1. 0 times 0 obviously is 0. 1 times 1, 1. 2 times 2, 4. So here's what my graph looks like. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. You should see kind of the basic U shape that you got going on there. And again, this is a graph, so make sure you are putting arrows at the end of those. Some of you are kind of bad whenever you graph lines and you don't put arrows on the end, so make sure you're putting arrows on here. Now, here's another thing. Since this is just the basic form, this y-axis right here serves as an axis of symmetry, and what I mean by that is this point should be an equal distance from that point. This point should be an equal distance to the y-axis as that point. So these lines aren't part of your graph. I'm just saying they need to be mirror images of each other. All right? And because this number, remember when you don't see a number in front of the letter, you assume it's a 1. And because that is a positive 1, your graph goes up. It opens upward. If I had something that looked like this, basically what that means is it would take everything over here and just do that. It would change the sign of all those. So what if I graphed that? What if I graphed -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. Do you see how just putting that negative sign in there caused my parabola, not my parabola, my parabola to now open down, only because that number in front of there was a negative. So that is something for your notes. If the number in front of the x is positive, your parabola will open up. All right? If the number in front of the x is negative, your parabola will open down, and it happens that way every time. Every time. Okay. The second one in the book, here it is. It's y equals -x squared plus 4. So right now that negative x, since we just talked about that, that should come to your brain that your parabola is going to look something like this. It's going to open down because that number right there is a negative. But what exactly does the graph look like? Where is it? So if we have XY chart, and I'm going to use my same old standbys that I love to use, 5 of them. If you use less than that, it really makes your graph hard to be symmetrical. So just try and keep that in there. All right, so I am going to do y equals negative. I'm going to plug these numbers in for x, and I'm going to add 4 to them. So if I put a -2 right here, now I do not do this first, right? That minus, that's only after I do the exponents. So order of operations, you have to do exponents before you multiply anyway. So I've really got -2 squared, which is 4. So I've got -4 plus 4, 0. -1 minus -1 squared plus 4. So this would be 1, -1 plus 4, 3. If I put in a 0, easy enough, there's no -0, so that would just going to be 4. If I put in a 1, so that would be 1, -1 plus 4, 3. And then if I put in a 2, so that's going to be 4, -4, and that's going to be 0. So if I plot those points, I've got -2, 0. I've got -1, 3. I've got 0, 4. I've got 1, 3. Whoops, 1, 3. And I've got 2, 0. So this is my parabola. Now, notice on here that my parabola did not look like this. It didn't go right there and then somehow curve in, right? So these are going to exponentially go out, out, out. It's going to be slow, right? But they should never curve back in on themselves. So they should always be considering to get bigger or smaller, however the case may be. But they will never curve back in. So please don't ever let your parabolas even go straight down. It's not going to go straight down. It'll continually just open wider and wider and wider. So make sure you're doing that, please. All right. So back to, let's get all this off of here. Let's go back to here. Clear this off of here. We've got a lot going on. And so those are the two that we just did. Looks exactly like that. Now, I also want to point out one thing to you here on this as well. This may be our basic function right here, right? That open down. But notice this plus 4. Doesn't that look eerily familiar to like a y-intercept that we've had before? And guess where it crossed the y? Right at +4. So that plus 4, +4, that's what it looks like. This one right here, let me scroll back up just that way you can see that real quick. Did not have a y-intercept. And if it didn't have a y-intercept, it would cross at where? 0. And guess where it crossed? Right at 0. So just something to point out to you on that. Okay, I want you to try A, please. Pause it and try it. All right, so if I'm trying my -2, -1, 0, 1, 2. So if I am squaring this, it'd be 4 times 6, 24. If I'm squaring this, it would be 1 times 6, 6. 0 would be 0. 1 squared, 6. 2 squared 4 would be 24. So if I want these, I'm probably going to have to make these a lot bigger. I'm going to have to maybe go by, I don't know, maybe 4, 8, 12, 16, 20, 24. Maybe I'll do something like that. Okay? So if I've got -2, 24, my dot is right there. -1, 6 would be in between 4 and 8. And 0, 0 obviously is right there. And again, no y-intercept. It does have a minimum point at 0. 1, 6, 2, 24. And again, I told you they are symmetrical, right? So if your lines aren't the same distance, if it didn't look symmetrical, if it doesn't look an even distance away on both sides, you've done something wrong. That is also an easy way to check it. All right? All right, so let's move on to the next page. Okay, 2 more examples here. I think that you can plug these in, right? I mean, if I say that we've got 0, 1, 2, 3, 4, 5, 6. Now notice this is a little different than my -2, -1, 0, 1, 2. Because we are talking about the distance in feet the race car will travel over t seconds. So can we have negative time? No. So we've got to use numbers also that make sense. All right, so in a word problem, usually things like that, we will do positive numbers only, usually, not always, but usually. So I think you can plug these in here without an issue, right? So you can take 0, square it, times it by 4. 1, square it, times it by 4. Okay, and you can get your points. That you can do. And even though they've got TD right here, you would normally just see something like this, and then you'd have to make that itself. So they've just kind of, these are the answers that they got, and they went ahead and put it with the time to make the ordered pair. They just kind of saved a step. So they took those right there and put it together. Now, with that, here's what I want to say about this. Anytime you have a coefficient in front of the variable that's squared, your parabola will be steeper. It will open up faster, so it will be narrower, okay? Down here in this one where it says 0.66d squared, yes, there's a number in front of it, but notice that is less than 1. All that means is like whenever you graph it, it's not going to rise as quickly, which that's not very symmetrical, but you kind of get my point. So that would look like that, whereas something like y equals 4x would look like that. It's going to be steeper. So that's just something I want you to keep in mind whenever you're doing these. Does this make sense? Okay, so again, if it's y equals -5x squared, which is one of the guided practice problems, you should know that not only should this open down, it should also be kind of narrow. All right? So if I had something like y equals 0.2x squared, that one's going to open up because this is positive, but it's only going to open up 0.2, so it's going to be wider. 0.2 is actually 1/5, so it's only going to open up 1/5 as fast as the normal one. All right, so those are a couple that I want you just to keep in mind whenever you're doing this today. Okay? So with that being said, I just want you to look at, we'll just look here at the bottom one, when it wants you to estimate. So that's our function that we just talked about, and we are using positive numbers only because we're not talking about negative distances or negative time like in number 3. How far could you see from a hot air balloon at 1,000 feet in the air? So once after you get your parabola, or at least half of your parabola graphed here, and it's asking you to estimate how far could you see 1,000 feet. So go to 1,000 feet, see where it crosses, where would it be? So it's not right at 40, but I would accept anything close, anything right underneath. Okay? So have fun with those. Have any questions, see me tomorrow. Good luck.